All right, so I guess we'll call this hypothesis testing basics part B, right? So we're looking at another problem here, and we have a random sample of 848 births. So that's n is equal to 848. Um, of those births, 430 were boys. So that's x is equal to 430. Significance level is alpha, that's 0.10. The claim is that 51.2% of newborn babies are boys. Okay, so this is a slightly different situation. Remember that the null hypothesis is always a statement of equality. So the claim in this problem is actually going to go into the null, right? So we're going to say the null hypothesis is that the population proportion is equal to 51.2% written as a decimal is 0.512. And then the alternate hypothesis is that it isn't, right? It isn't. Um, okay, so here, let me just switch over to what I wrote down. And I'm going to show you something to give you a little bit more insight on hypothesis testing, because this is, in fact, one of the more challenging things in the course. All right, so this is what I wrote down so far. All right, so just to give you some insight, I'm going to make a normal curve, right? And at the center of this normal curve is going to be the value 0.512. So what is our p hat? What do we get out of this? 430 out of 848. So let me just calculate p hat. 430 divided by 848 is going to give me 0.507 if we round it to three decimals. So let me write that here. It's equal to 0.507. Well, heck, I mean, I guess I don't even really need to conduct a hypothesis test. So what are we looking to find out here, right? And I'll let you know what I mean. This 0.507 is so close to 0.512. Um, you know, so what type of test is this? Because of this inequality, right? This is known as a two-tailed test. So I'm going to make two tails, right? And we're looking to see, does this number 0.507, does that fall? Remember, our significance level is 0.10. That means I got 0.05 in this area right here, which we'll call a rejection region, right? And I've got 0.05 in this area right here, which we'll also call a rejection region, okay? So does this number, this 0.507, does this fall in this area where, you know, where we do not reject the null, or does it fall in this area right here where we do reject the null? And that's essentially what we're looking to find out. All right. So this is a different way to look at it. But this is what's going on. So I'm going to go ahead and go to StatCrunch. I think I might even still have a StatCrunch open from the previous problem. Okay, so I do have StatCrunch open from the previous problem. So what I'm going to do is I'm going to go to options. I'm going to go to edit. You know what? Let's just go back out so I can show you how to do this again. We'll go to stat, then we'll go to proportion stats, then we'll go to one sample, and then with summary. So this is everything that I've written down. I have the number of successes is 430. And then the number of observations is 848. We're testing to see if P is equal to 0.512 or if P is not equal to 0.512. So we don't have to change anything here. We have a significance level of 0.10. Really, ultimately, all that's going to do is change our critical value, right? So I'm going to hit compute. And here's my output. So from this output, I have my population proportion is what we're testing. I have a count of 430 out of a total of 848. Sample proportion is 0.507. There's our standard error. So our Z statistic, remember, that's the measure of how many standard deviations we are away from the mean. That is that's very close to the mean, right? As we could tell just by the initial numbers. But so we have a Z-stat, or a test statistic, we could call it, right, of negative 0.28. I'm writing that down. And then we have a critical Z of 1.64. And remember, that's plus or minus 1.64, since this is a two-tailed test. So we'll say plus or minus 1.64. And a super, super high p-value of 0.7742. If the p is high, the null will fly. In other words, we don't reject the null when we have a p-value that is that big, right? We have a significance level of 0.10 and a p-value of 0.7742. So I'm going to go back to this piece of paper I've been writing on. So these critical values, that tells us that we have 1.64 there, and then this line right here will be negative 1.64. Our test statistic is negative 0.28. So that's going to be like here somewhere, right? So clearly this test statistic is not far enough to the left or to the right to fall in the rejection region. And then we'll go back and we'll enter some numbers into the problem. Okay, so we have a p equal to and then not equal to. So this should be the first answer. Our test statistic is negative 0.28. So that should be our second answer. The p-value is a gaudy 0.774. And what is our conclusion? Well, we will not be rejecting the null. We don't have sufficient evidence to warrant rejection of this claim. And then this is where the wording gets kind of funny, right? Because you never accept the null hypothesis. You just don't reject it. So the results do not support the belief that 51.2% of newborn babies are boys. They merely show that there is not evidence against that. And that's the cautious language of statisticians. Okay, and that concludes this lesson.